Okay, so right here, this chart, what we want to do is we want to convert our rational exponents to radical notation. So in the previous module, we talked about going from a fraction to radical notation. We use the acronym TIBO, which stands for top, inside, bottom, outside. So TIBO. Okay, which what we will do is this. You're going to take the base of the exponent. You're going to write it down with your radical sign. The top of the fraction, so the top of this 1/2, goes inside the radical, right there. The bottom of the fraction goes outside the radical. So top, inside, bottom, outside. Now, in this case, I don't need to write 169 to the first, so I just write it as 169. I didn't mean to erase that. Just the 1. There we go. I also don't need to write second root. Okay, so anytime that I have just a square root symbol, it is understood that it's the second root because there is no such thing as the first root. That contradicts the definition of a square root. So I just need to write 1/2 power as the square root. Okay, and then in this case, I would take the square root of 169, which is 13. So our square root button, second square root, 169 gives us 13. Okay, so if we take a look at the second one, we do have a fraction. The entire fraction is in parentheses, so the entire fraction will go into our radical. So we'll do our radical sign, and then we'll have 81 over 625. The top of the fraction will go inside the radical, the bottom outside. I don't need to keep the 1 inside the radical, but I do need to keep the 4 to indicate that that is a fourth root. And then here I can take the fourth root of each of these, I believe. So fourth root of 81. In everybody's calculator is going to be different, but you would want to look for that x root or maybe a blank with the square root. In this calculator, the way I would do that is go 4 and then math. And then it's going to be number 5, the x root of 81. So that would be 3. And then for 625, 4, math, x root of 625. And that would be 5. So fourth root of 81 is 3. Fourth root of 625 is 5. So we get 3/5. Okay, our next two, notice that you've got parentheses on one and no parentheses on the other. So for 4m to the 1/3, that 1/3, is that going to go to just the m or both the 4 and the m? Just the m, okay, because it's only next to the m. If it wanted to go to both, you'd have a parentheses. Okay, so this is going to be 4 times, and then this is going to be m inside the radical. The first power on the top, we don't need to write that. Bottom outside, we do need to write that. So 4 times cube root of m. And then we don't know what m is, so we would leave it just like that. Now the second one, this 1/2, does that go to the 49 and the x or just the x? This time, yes, it goes to both, okay, because of the parentheses. So that means that's 49 to the 1/2 and then x to the 8 times 1/2, which is just 4. Okay, now take the 49 to the 1/2, that goes inside the radical, 49. First power, I can write it, I don't need to. Second one, I don't need to. But what is the square root of 49? 7, yeah. So then that is just going to be 7 and then x to the 4th. Okay, now we have -8 to the 1/3. The negative sign is inside of the parentheses. So under the radical, I'm going to put the -8. And then this is to the first power. I don't need the first power, but I do need the cube root. So the cube root of -8 is what? Can I take the cube root of a negative?
Yeah.
I can, yeah. I can't take the cube or the square root of a negative, right? But cube root, I can. So any odd roots, it's okay. Cube root of 8 is 2. So the cube root of -8 is going to be -2. And then notice how the 16 is written differently. This 16 isn't in parentheses. So right away, I'm going to go ahead and rewrite that as -1 times 16 to the 1/4. So then this is -1 times, it's going to be 16, the top inside, bottom outside. So 4th root of 16, which in this case is, I can't type today, 2. Okay, so 4th root of 16 is 2. So then that means this is -1 times 2, so -2. Okay. An important part of doing these problems is reading the instructions, knowing where to start. So if it says to use rational exponents, that means that you want to use the fraction exponents. If it says use radical notation, then use square roots. Write with positive exponents means if you have any negative exponents in the final answer, you're going to move them across the division line. And then sometimes we get issues with negative in the calculator, which let's see if we would get that in this case. So let's say I wanted to put this in my calculator. I could. I would go parentheses, -27, raise, so my little up caret here, parentheses 2/3, 2 divided by 3. Yeah, this should be okay. As long as you're using parentheses in the calculator, it should be okay. But that's if you have a more advanced one, which you don't need for this course. You can do these by hand. Some of like the TI-30 just X for the class, I don't think it has as much. It has a parentheses. It just doesn't always compute it as, sometimes it gives you an error. So anyway, what you want to do is you would always want to check it anyway in this case. So use radical notation means convert this to radical. So underneath my radical, I'm going to have a -27. And then the top goes on the inside. So I'm going to just put the 2 on the inside, the bottom on the outside. And then I want to work that. So -27 squared is going to be -27 times -27, which is going to give me a positive 729, which means I have the cube root of 729. And then I'm going to take that. So for me, that's in math again, just math. Then I actually have a cube root button. And then 729. So I think on the 30x, you just have the x root button. I actually brought one today. Yeah, you guys, the second of the up caret, you would just do 3, and then second, the x root, and then type the number out. So that is going to be 9. Okay, so let's look at another example. So write this in radical notation. Very, very similar problem. Underneath the radical, I have a -16. The top of the fraction goes inside the radical, the bottom outside. And then we'll work that out. So -16 to the third is going to be, let's see, -16 to the third negative 4,096. And now this one, I think this will give us a domain error because you can't take an even root with a negative number there. So, and I think if we put this in the calculator, just as is, it should give us an error there. So we might just leave it. Yeah, so it gives you that. So let's just leave it as fourth root of negative 4,096 for that. Yeah. The fourth root of negative 4, no, yeah, it should. Although it actually might just, if it just says write it in radical notation, it might just want it like this. Like not even actually fully simplifying it. If you can fully simplify it, you will, but then if you can't, you're going to leave it in the radical notation. Okay, and then this one just wants you to write this with positive exponents. So the negative exponent means this is going to drop into the denominator. So here we would go 1 over negative 64 to the positive 2/3. And then that's just writing it with positive exponents. It might want us to keep going. Again, that's something, kind of play around with your homework and see if it'll accept that. It might say that is correct, but please continue the problem, right? So this should work out because under the radical here, you have negative 64 squared, which will become positive, and then cube root. So top inside the radical, bottom outside. So let's see, negative 64 squared is 4,096. And then 1 over the cube root of 4,096. Is that going to give us a nice answer? $16. So 1/16. Okay, so this is the answer with positive exponents right here. And then this is the answer fully simplified. Okay, so 2 practice problems. Take about 5 minutes to work on those, and then I will go over them. And then we'll continue with the module. Okay, let's go ahead and do these 2 problems. Okay, so for this one, the 1/3, is that going to the m or both the 5 and the m? Just the m. Okay, so just there. So it's going to be 5 times, and then we're going to put the m in the radical. On the inside, we've got the 1, so we don't need to write that, and the bottom goes on the outside. So 5 times the cube root of m. I write the multiplication symbol just because I want to separate it enough so it doesn't look like 53, but you don't have to write it. All right, and then the next one, what would be the first thing I want to do here? Yeah, so take the x that goes to the negative 5/6 is going to go just to the x. And I want it to be a positive exponent, so I need to move it to the top here. So x to the 5/6 will go up here. So then I'm left with 5x to the 5/6 over 11. It says to simplify. Can we simplify any further from that? I don't think we can with 5 over 11. It doesn't say to put it in radical form. If it wanted you to, you could do 5 and then times x, and then the top would be 5 on the inside, bottom outside, all over 11. If it wanted in radical form, but I think just with this one, positive exponents and simplify, you're going to leave it like that. So that's rational form. And then this is radical form. Okay, so now we're going to bring in some more problems with our exponent rules, which basically means we're doing all of our exponent rules we learned back in Module 2, Homework 5. So if you need to review this, it's Module 2, Homework 5. But now we're doing them with fractions. So adding, subtracting, multiplying fractions is what we're doing here. So for our first example, we have the same base, and that would be like, last one here, quotient rule. So we will subtract top to bottom. Now when you're dealing with fractions, sometimes you don't know which one's bigger, so it's always important just to go top to bottom and then simplify from there. So for this, we're going to go 5/3 minus 4/3. So that's pretty simple because they already have a common denominator, so we'll just do 5 minus 4, which will give us 1/3. So then our answer is just x to the 1/3. Now if you flip the page, you will see it gets a little more complicated. Okay, so first thing we'll want to do for example 2 is work with your negative exponents. So we're going to take the negative exponent here. We're going to bring this up. So that's going to be x to the 1/3 in the top. I don't have a denominator anymore. Okay, but I do have an x to the first and an x to the 1/3. So what do I want to do with those exponents? I want to add them. So this is x to the 1 plus 1/3. Okay, which means I'm going to need a common denominator, which would be what? 3. So this would be 1 times 1, or 1 times 3 would be 3. So 3 over 3. And then we add straight across the top. So that would give us a 4/3. Okay, so I get x to the 4/3 there. And I just have that 4. So this is going to be 4 x to the 4/3. Okay, we're going to leave everything in rational form unless it asks us to put it in radical form. So with these ones, we're keeping them rational. Okay, then we have example 3. Okay, so first thing I want to do here is I want to distribute the exponents. So I'm going to write that out here. So we're going to distribute the exponents. So I'm going to take the 1/6, distribute that on the top. So let's see, that's going to give me x to the 5 times 1/6 will be 5/6. And then 4 times 1/6 will be 4/6. So we're just multiplying, this is like 4 over 1 and 5 over 1. Okay, then on the bottom, I distribute the negative 1/3. So this is going to be x to the negative 5 times negative 1 will give us a positive 5/3. And then y to the negative 2 times negative 1, positive 2/3. So the next thing I would do is I would take care of any negative exponents, but it looks like I don't have any here. But I'm writing that just in case you encounter one in a problem. Okay, then we're going to do product and quotient rule. And then we'll simplify. So those are your steps. Okay, so let's go ahead and start with the x's. They're being divided. So what do I want to do with them? Subtract. All right, so this is x to the 5/6 minus 5/3. So I need a common denominator, which would be 6. So I need to multiply this by 2 over 2, which makes this x to the 5/6 minus 5 times 2, 10, 6. Which gives us x to the 5 minus 10, negative 5 over 6. So we just go straight across the top, subtract 5 minus 10, we get negative 5/6. Okay, now we'll do the same thing with the y's. So I have y to the 4/6 minus 2/3. You guys notice anything about that right off the bat? Aren't they the same? Isn't 4/6 2/3 equivalent fractions? So you could, if you notice that, you could just do it like that. But let's work it through just so you can see. So this I would multiply by 2 over 2, which gives us y to the 4/6 minus 2 times 2, 4, 3 times 2, 6, which gives us 0. Okay, so now we're looking at this problem here. So we've got x to the negative 5/6, y to the 0. What is anything to the 0 power? 1. Okay, so this cancels out. You can write it as a 1. Let's go ahead and we'll write it as a 1. Then we want to simplify the negative exponent. So what happens to the negative 5/6? Drop it down. So this becomes x to the 5/6 in the denominator. Our final answer, 1 over x to the 5/6. What's really important with problems like this when you see them and they look big like that is to just go slow, try not to rush, because a lot of the mistakes don't happen in the procedure. What I saw on a lot of your problems was that if you knew how to do the procedure, so if you even started the problem, you guys did the procedure mostly correct. The issue a lot of the times was something as simple as saying that 5 times 2 is 5 instead of 10. So just little mistakes like that. So take your time and break it down piece by piece, just double checking your multiplication, addition, subtraction, things like that. Okay, we have one more example. Now this one we're in a radical form and then we want to use rational exponents. We want to answer it in rational form, which is fractions. So what you want to first do here is convert from radical to rational, which means we'll use the same acronym. So I've got y to the top of the fraction will come from inside the radical, which is an understood 1. The bottom of the fraction will come from outside of the radical, so it's going to be 4. And then times y to the top of the fraction comes from inside, so 3. The bottom of the fraction outside, so 4. So I have y to the 1/4 times y to the 3/5. What am I going to do with these exponents? And I'm going to add them. So I want to add 1/4 plus 3/5. Common denominator 20. So multiply by 5 and 4. All right, so this is going to give us 5 over 20 plus 3 times 4 is 12 over 20. And then straight across the top, 5 plus 12 is 17 over 20. So our exponent is 17 over 20. Our answer is y to the 17 over 20. And we leave it in that form because we want to leave it as rational exponents.